Today we're going to learn about 1.5 factoring trinomials by logical reasoning.
Wow.
So, last time we learned about decomposition as a method for factoring, and although it's like a foolproof algorithmic method, sometimes it can take up a lot of room and a lot of space, and sometimes we can find a more efficient way so that we could write down fewer steps and do some of that thinking in our minds. So, today we're going to talk about logical reasoning, but before we start that, we're going to just go ahead and re-expand and simplify a product of binomials so that we can think about where that came from, where those numbers are going, what's happening, and all that fun stuff. So, as we remember, as an acronym to help us remember how to do that double distribution, we have FOIL, right? And to FOIL, we start with F, our firsts, so 2x times 3x, so that gives us 6x squared. Then our outsides, which is 2x times negative 5, which gives us negative 10x. Then we have our insides, which is our 7 times 3x, which gives us a plus 21x. And then we have our lasts, our 7 times negative 5, which gives us negative 35. Now, I wrote this a little bit too high for my liking, so I'm just going to scoot this down a bit. Now, just to make things insanely clear here, I'm going to label what those are. So that was our firsts. This is our outsides. This is our insides. This is our lasts. And the values or terms that correspond with that, these are our firsts, our outsides, our insides, our lasts. Now, as you notice, when we simplify, we collect our like terms. So we're going to have our 6x squared and our negative 35 remain, but then we're going to collect or combine our negative 10x and our 21x to give us plus 11x. And I'm going to scoot this negative 35 closer to make it less awkward looking. Now, as we did this, notice that our B term is really a combination of our OI. Okay? All right. But our firsts and our lasts remain the same. So let's take a peek here. How did we get the first term? How did we get our 6x squared? Well, that was from multiplying our firsts together. That's from multiplying our first term in our binomials together. Well, okay, fine. We figured out how we got our first term, but how do we get our last term? Well, our last term is again just found by multiplying our last terms in our binomial together. So, that's ugly, yes. That's from multiplying our last terms in our binomials together. Okay, fine. But how did we get our middle term? I don't want that color blue. I want the one. And remember that term we didn't get directly, right? That comes from our OI. That comes from multiplying our outsides. That comes from multiplying our insides and then collecting those terms together. So, what did we do? We multiplied our last, I'm going to say last, I'm not going to say last, I'm going to say our outside terms together. And we multiplied our inside terms together. and added their products. So we took the result of our OI and then we combined them. So that's where all of those values came from. So the first term comes from our multiplication of our first terms. Our last term comes from the multiplication of our last terms. Our middle term comes from the OI. All right. So when we're using our logical reasoning as a method to factor, we're really looking at where those terms came from. So understanding that the first comes from multiplying the first, the last comes from multiplying the last, and the middle comes from multiplying our outsides and insides and then adding their products, that's going to be super useful and helping us kind of make that link in how the factoring method works. So the one similarity that it shares with decomp is that we're still going to have that same first step in the sense that we are going to examine the factor pairs of A times C that sum to B. So that's going to help tell us what our outside and inside products, our OI products, should be. And that's the one similarity that those two methods have.
On this next page, we're going to do one whole entire example.
But I
We're
thought
going
you
to really
said,
go through that process.
I thought you said logical reasoning should take up less room.
Oh, it should take up less room, but we're really going to just show all of the steps one piece at a time. So really, by the end, we'd have written all of this in one spot, but we're just going to break it down step by step. Oh, look, we're brilliant. So first step is to determine factor pairs of negative 40 that sum up to negative 3. If you want, pause, think about that for a bit, come back when you've got an answer, go for it. I'm going to write down some numbers. What number shall I write down? I think I will write down negative 8 and positive 5. So I chose negative 40 because that was 10 times negative 4. And it had to add up to negative 3 because that was our coefficient of the middle term of just x. So again, negative 8 times 5, that's what we're going with. I know that if this thing is factorable, it's going to look like this. It's going to have two sets of brackets. I don't know what's in those brackets yet, but I know it's going to have those. And in multiplying those brackets together, I'll have my little arcs for FOIL, F-O-I-N-L. And on top of each one of those arcs, I can write down what its product is supposed to be. So if I multiply the first terms together, just as we showed on the last page, we should get the first term of the trinomial. We should get 10x squared. Hence, we have 10x squared over here. If we multiply the last terms of the trinomial, or the last terms of the two binomials, we should get the last term of the trinomial, which was negative 4. Hence, we've written negative 4 here. And then what about those other two arcs? Well, that's the OI. And our OI adds up to negative 3x. How does it do that? Well, with a negative 8x and a 5x. So we've written those on top of each one of those arcs. And now knowing what those products are supposed to be, we can proceed. We can start asking ourselves, well, how could these two terms, these first terms, multiply to give us 10x squared? Perhaps they could be x and 10x. And that could look good, except that then we look at this 10x being here and say, well, 10x times something has to give us 5x? That's not going to really work out with integers. So it can't be x and 10x. Okay. Well, then what if I put 10x and x? Just go the other way around. That works here, right? Because I can say x times something is 5x, but I can't say 10x times something gives me negative 8x. So that's a hard no. It can't be 10x and x. which must mean that I'm going with something like maybe 5x and 2x, but again, 2x times some integer giving me 5x. That's not going to happen. Hence, it must be 2x and 5x in that order. And from there, we can keep piecing things in. We can figure out what this is. We can figure out what this is. For this first blank spot, we know that this value, whatever it is, being multiplied by 5x has to give us 5x. That's what's over that arc. Therefore, this must just be a plus 1. And similarly, this last piece here has to multiply by 2x to give us 8x. So 2x times something gives us 8x. Well, it must be negative 2. And that's how, well, negative 4. I knew that. I knew that negative 2 times 2 is 4. Anyways, this must be negative 4. That's what multiplies by 2 to give you 8. I figured it out. I know my times tables. I'm a genius. Don't mean to brag. So we fill in all those pieces one at a time until we've got our final factored form there. Again, we can always check that over just to make sure it works. And also, again, we do not need all this space to do that. Right? All of this could have just been written right here. So it's shown in all those steps just to really break down what you should be thinking at each point in time. You can also process that mentally, so you don't have to actually write down each of these arcs or list what they are. But if you want to, that's up to you. Feel free to do so. Go for it. Follow your heart. Follow your dreams. Whatever helps you actually process these. You can still draw the arcs, but again, just not completely necessary. Whatever you find most efficient, go with that. So let's perhaps try a few of these.
Alrighty, so we're going to start with this guy here. And just to help me remember, especially for the first examples that we're going to do, I know that my first terms comes from my f, my multiplying the first two terms of my binomial together. My last term comes from multiplying the last two terms of my binomial together. And my middle term comes from multiplying my outsides terms together and multiplying my inside terms together and then adding those products. So that is where everything is coming from. The first thing I'm going to do when I look at something like this is I'm going to multiply my A times C together, so I get 1 times 24 to get 24. And I'm going to look for factors of 24 that add to give me positive 14. And you can go ahead and think about that for a while if you wish, but I know that that's going to be 12 and 2. So that is where my OI is going to come from. One of those are going to multiply to give me 12x. One of them is going to multiply to give me 2x. Now, when I do logical reasoning, at least when I do examples with you, I like to draw those arcs in so that you can help see my thinking. Because sometimes if I just pull those numbers out of nowhere, you can't see what I'm processing. However, you don't need to do that like Mr. A said. You don't need to draw in those arcs if you don't desire. What you do need to do is make sure you still have those equal signs, because I'm saying that this top trinomial is going to be equal to whatever the heck I write down here. So I know I'm going to end up with something factored, and I like to draw in those arcs, right? So I'm going to draw my first, my outsides, my insides, my lasts. And I wrote that a little bit too high for my liking, so I'm just going to scoot that down a little bit. All right. And I'm going to label all those arcs as well. So my firsts, I need to end up with x squared. My outsides, I either need to end up with 12x or 2x. But in this case, it doesn't really matter. So I'm going to put 12x first, and I'll put 2x in my insides. And then my last, I'll put 24. All right. So here, this is where I'm going to start by my logical reasoning. I'm going to look at my firsts first. What are two things that will multiply to give me x squared? That will also help satisfy the other multiplication. So I'm going to put an x here and an x here because this x will not only help to get this product, but it also helped me to get this product down the road. X times something will give me 12x. Same for this x here. It'll help me with this product to get my x squared, but it also assists me in eventually getting that product of 2x. Alrighty. Now I'm going to look at these and logically reason what the rest of them should be. I know that this term here should multiply with this term here to give me 12x. Well, what times x will give me 12x? Well, that's going to be positive 12. And if I want to find out this term here, well, this times x should give me 2x. And in a similar way, this times 12 should give me 24. Oh, it kind of looks like a smiley face. Cute. And that is going to be a positive 2. Right? So we end up having x plus 2 times x plus 12 as my factored form.
I will try some, I think.
Okay.
Ooh, but what color shall I use? Woof. I will try this one in, I don't know, orange. I'm going to say this thing can be factored. It must be able to be factored into a couple binomials. But what will those binomials be? Well, according to these pinkish lines, we'll have 4 products, each one of those products being of a certain value. So the product of my first terms must be x squared, because that's my f of the foil. My last arc, my product of the last terms must be 9, because that's the L of the foil. And then something has to go here and here. And I need something that multiplies to 9, but adds up to 10. In which case, I'll go with, I think, 9 and 1. Oopsie daisy. Nice. So I'll just go with 9x and x. And I can start filling things in. Again, with this being just an x squared, only one way to get that, so that's all kind of nice. We can just say that's x and x. And then last up, are we going to say that 9 comes from a 3, or what are we going to do? Well, we'll use these to our advantage. 9x is the result of x times something, specifically x times positive 9. And then how are we going to get this one? Well, there's a couple of ways. We can say it's the result of x times something giving us x, or we can say that 9 times something gives us 9. However you do it, you should get that that's a plus 1.
Alrighty, let's check out this next guy.
Okay.
Alright. I know that when I factor this, I'm going to end up with the product of 2 binomials. And I know that I'm going to draw in those lines here, my first, but I don't want them in purple. I want them in this kind of color here. I'm going to draw in my Maui hook. And I need to figure out how my middle term, my B term, is going to be split up to help me with that OI. So I am looking for the factors of my A times C of negative 180 that add to give me positive 3. And I want you to try and think about those on your own for a second, right? Because those aren't super obvious. They take some time, but you could do it. Because you could do anything. And we believe in you.
Believe in yourselves. Believe in the dream.
That seems like enough belief for now. And hopefully you went and found out that you had 15 and negative 12. Right? Those multiply to give me negative 180, but then add to give me positive 3. Now, when I do this, I know that my first should give me x squared. My outside should give me, let's say, 15x. My inside should give me negative 12x. My last should give me negative 180. Alright, and now I'm going to start placing numbers in accordingly. So I know that each of these binomials need to have an x there, which is good because those two will multiply to give me this x squared. Next, I'm looking at this value here. Why that value here and why not this one? I don't know, personal preference. So I'm going to look for this guy here, and I know that that yellow blob has to multiply with an x to give me 15x, and that yellow blob ends up being positive 15. And last but not least, this yellow blob needs to multiply with x to give me negative 12x, but also needs to multiply with my positive 15 to give me negative 180. And of course, that value is going to be negative 12.
Well, this next example.
It looks like we have ourselves a trinomial, which I'm going to hope can be factored into a pair of binomials. That's the real dream. So I'm going to set up some arcs. That first term, those first terms must multiply to give me x squared. These, I'm not talking about the oi, just so we're clear. These last terms must multiply to give me negative 63. And if I take a look at my inside terms, wait, that's not my inside.
Those are your inside, but you want to draw your
I did want to draw it there. You're right. Thank you. Gosh, art's hard. All right, inside and outside terms. That now I have the Maui hook.
Yeah,
there, I see it.
Yeah.
I see the Maui hook. That has to add up to give me negative 2. So let me just figure that out real quick, like on the side. Nobody look at what I'm doing. Just kidding. You can look. Has to multiply and add up to negative 2. I'm just going to go straight up. There's a 9 that's negative and 7. So, I don't know, let's put the negative 9x here. Let's put the 7x there. That seems legitimate. Perhaps overly legitimate. X and x. That's the only way I can get an x squared. And then piecing together the rest. This times x will give me 7x. So that has to be plus 7. And then this times this will have to give me negative 63. So that must be negative 9. And just quick double check. This outside product is giving me negative 9x, which it's supposed to. Super duper.
Now, for these first four examples, what you've noticed, or may have noticed, that our a value has always been 1. Yeah?
Oh, yeah.
And what I really notice when I have an a value of 1 is that let's pick a different color here. Highlight, what color do I want? Ooh, purple. Okay, so I notice that the numbers that I end up with in my binomial are actually the same as the factors of my a times c that add up to be my b value. So here I had 2 and 12, and look, I have 2 and 12. Here I had, he didn't write them down, but that's fine, we know. We had 1 and 9, and we have 1 and 9. Here we had 15 and negative 12, here we have 15 and negative 12. Here we have 7 and negative 9, and here we have 7 and negative 9. So if you've noticed that pattern is actually true for all cases only when my a value is 1. right? So if you notice that pattern and that helps you factor down the road, ooh, baby, take it. But otherwise, if our A value is not 1, excuse me, got a little tickle in my throat, then we need to continue that logical reasoning process. But if you notice that my A value is 1, go ahead, take that pattern, because it will get you to the correct answer. Alrighty. But here sadly, so sadly, my A value is 2! The horror! Alright. It's actually not that bad. So I'm going to take a look at this guy here. I'm going to start by multiplying my A times C. I end up with negative 90. And now I'm going to look for factors of negative 90 that add to give me negative 1. And I see negative 10 and positive 9. Alright. Now, when I go ahead and know that my factor will give me, or my factoring will give me a product of 2 binomials, I'm going to draw in all my arcs, make my Mauer's hook, whoop, 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 and I'm going to label what all of those are going to be. I'm going to start with my firsts. I know my firsts will multiply to give me my first term, which is my 2x squared. My lasts will multiply to give me my last term, which is my negative 45. Now, for my OI, I know one of those arcs will have a negative 10x, and one of those arcs will have a 9x. Okay? So I'm going to go and put them in. So I'm going to put, I don't know, let's put 9x here, negative 10x there. I don't know. Feel the mood. Let it move you. Now, because of this 2x squared, I'm not just going to have a 2x and, I'm not going to just have I'm not just going to have an x and an x, right? Like before we had an x and an x. We're not going to have that anymore. At least one of those values is going to have some coefficient that's not 1. I don't want that colored. Come on. Here we go. So to get 2x squared, I'm going to have to multiply x by 2x. But which one is going to get that 2x? If I put a 2x here, yes, it'll help me satisfy this product, but it won't help me satisfy that product, right? Because I put the 9x on that outside arc. Nothing, no whole number or whole integer will multiply with 2x to give me 9x. So that's not going to be good. So instead of putting a 2x there, I'm going to put the 2x here. I'm actually going to move this x over. I'm feeling a little crowded. Because the 2x, again, will help me with the 2x squared. That's great. But this 2x will also help me with that negative 10x. So I need to do a little bit of thinking of where I'm going to place it. It's a little bit strategic. But again, just logically thinking through it, I can decipher that pretty easily. Now that I know where my x and my 2x belong, I can figure out those missing pieces. So what goes here? Well, I know it's going to be this guy times x will give me 9x. So what is that? That is going to be, that's going to be a positive 9. And what's going to go here? Well, I know this yellow blob times 2x will give me negative 10x. Well, that missing piece there would be negative 5. And I could go and double check and make sure all of my products work. So this negative 5 and that 9 do in fact multiply to give me that negative 45. All right, some additional thinking when we don't have A values of 1.
Whoa, there's some big numbers. It's alright. I'm a champion. I can do anything. But I'm probably going to write down that A times C is something. A times 21, we're probably looking at like 168. Woo! And, oh yeah, that's a negative over there. So, Bloop, bloop. Negative 168. So I need factor pairs of negative 168 that add up to positive 17. And off the top of my head, that will be something. I just actually don't know what. It's not going to be 21 and 8, because that doesn't add up. What else goes into this? 6? 6 goes into this? How many times does 6 go into 168? I don't even know. 6 goes into 16 twice. 28. That's not that either. I need maybe a 7? 7. 7 going into 168. That happens twice. 14, got a 2, 8, 24. I think we have a winner. I think it's positive 24, negative 7. Just noting that those were 17 apart, hence the 17 there. Blah. Blah, 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 blah. Blah. Alright, so that took a little bit of extra effort. It's alright, we always put in maximum effort. So this thing is equal to the product of a couple binomials where what colors will just not go together? First, outside, inside, last, and maybe shift this whole operation down a smidge. Let's get orange in here. So these first ones are 8x squared. These last ones, negative 21. Inside I can say is 24. Inside I said was... Outside's 24, inside's negative 7. Shaboom.
Does it matter if I put the 24 on the inside from the negative 7 on the outside?
Look, I'm going to answer you, and I'm going to answer you in one word. No. No, it does not matter. If I choose to say the other way around and put my negative 7 up here and my 24 down there, I will still get the same result, but perhaps in a different order. So, just like 3 times 4 is the same thing as 4 times 3, looking at something like this above example, x minus 9 times x plus 7 will be the same as this jazz here. So that's all that'll happen if we swap those two around. So it does not matter what order the factors we end up with are in, just that we get those two factors. Blah, 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 blah. But I chose a certain way the first time, and I'm just going to stick with it because I like it. I'm ready to go. Alright, I got myself some options here. 8x squared. There's a bunch of ways I can get that. I'm thinking maybe 4x and 2x, but no, that's not going to give me this inside product with a 2x times something is 7. In fact, I don't think I can put any even number there at all, so I can't even put a 4x there. So definitely not 2x and 4x. Alright, that's out. Which leaves me just 8x and x, and I know already I'm not putting an 8 here because of this. So it must be that I'm putting 8x and x. And from there, piece together the rest. 8x times something is 24. That something must be 3. 3 times something is negative 21. That must be negative 7. And just double check, negative 7 times x does in fact give me negative 7. So this house is clear.
Alrighty, next. We have, well, we're going to start by going a times c, and 9 times negative 5 is going to give me negative 45. And I am looking for factors of negative 45 that give me positive 4. And what I notice right away is 9 and 5 are factors of 45, and they're 4 away But I can't do 9 and negative 5 because that would give me, oh, positive 4. That's actually what I'm looking for. So I can do that.
Yeah.
9 and negative 5. Whoop, whoop. All right. Now, I know this thing-a-ling is going to factor as a product of 2 binomials. And I like drawing in them arcs though. Boop, 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 boop. Oh, I don't like that last one though. Boop. Oh. Oh my goodness.
Third time's the charm.
No. Okay.
Okay, yeah.
That's much better.
That was good.
Whew. All right. And I'm going to fill in what each of those arcs should be. So I know I get my first term by multiplying my first together, so I'm going to get that. These two will multiply to give me 9x squared. I know that my last term is found by multiplying my lasts together. And, oh wait, I'm going to shift this down as well. Whoop, whoop. I know that my outsides and my insides, well, they are going to be 9x and negative 5x. And again, it doesn't matter which one's which. It'll just change the order of your answer, but doesn't change the accuracy of it. Alrighty. Now, as I'm doing my thing, and I'm trying to figure out what goes where, I always start with my x squared term. I know that I'm going to have something x and something x. Well, is it 3 and 3? Well, if I put a 3 here and a 3 here, this 3 will help me make that 9x, so that's kind of cool. This 3 will help me make this 9x squared, which is cool. So that 3x is okay. But what about this 3x? This 3x will help me with this 9x squared. Nice. But this 3x will be useless to me to help me find that negative 5x. No dice, not happening, not in this house. So with that being said, we can have 3 and 3. What about 9 and 1? Right, so if I have my 9 there, again, 9 helps me with this. 9 helps me with that, so that's kind of cool. This x helps me with this. Nice. This x helps me with that. Ooh, baby, that will work. Okay, so with logical reasoning, right, even though it's less written out steps than decomp, sometimes it involves more mental steps, right? Because you have to think, does it work? Why does it work? Why does it not work? And then kind of work through those different options. Alrighty, so I've got my 9x, I've got my x, now I'm just filling in the missing pieces. So this yellow blob multiplies with 9x to give me 9x. Well, that yellow blob, my friends, would be plus 1. Let's find the other yellow blob. This yellow blob multiplies with x to give me negative 5x. Well, that yellow blob would have to be negative 5. And let's just double check that as well. Does this negative 5 help to give me this negative 5? Yes, indeed it does. Woot, woot. That is complete. We've only got the final example.
I'm done. So I have to speak, so I can't beatbox over here. Anyways, I'm gonna have 2 sets of brackets. And I'm gonna put stuff in there. I'm not much of a singer, sorry. I will have some first terms. They will multiply to 4x squared. I'm gonna have some outside, inside. I'm gonna have some last. I lost my spot. Just kidding. These will be 9. So I need 36 to break down into 2 things. That will add up to 20. Ooh, you should see that right away, fortunately. We got 18 and 2. So, 18x, 2x. And yeah, I'm just going to fill this in with no. that orange right there. His house is going down. All right, 4x squared. How's this gonna do? Can't be 4x and x because of this business. Can't be x and 4x because of that business. So we must be dealing with 2x and 2x. And I'll fill in the rest. 2x times something will give us 18x. Signs point to it being 9. 9 times something gives us 9. According to my math, that's 1. And final check, 1 times 2x certainly does give us 2x. This thing is done.
And with that last example, we are done all of the notes for today. So there are some practice questions in the textbook if you want to give those a go. And you notice that this is another quiz point.
Whoa!
So, since our last quiz was from 1.1 to 1.3, this quiz will just cover 1.4 to this, which is 1.5. So factoring by decomp and factoring with logical reasoning.
And maybe a small dose of multiplying binomials together as well.
Yeah. So we'll tell you in class when to expect that quiz. But otherwise, that's all for now. Ta-ta!
Man, that's all for now, ta-ta. Who doesn't say like ta-ta for now? TTFN.
Sorry.
Yeah, that's okay. It's okay.
TTFN, ta-ta for now!
Adios, muchachos. Look at me, I'm Miss Thibodeau. That's what I say.